So we've been doing some problems that involve finding the minimum or the maximum value. Now we're going to actually apply that by doing what's called optimization problems. So basically what you do for these types of problems is that you write a formula, we call that the primary formula, then you're going to take the derivative of that and find the minimum or maximum value. Occasionally you will need a secondary equation. I'll give you an example where we do that. So let's just go ahead and do an example. We have a manufacturer who wants to design an open box that has a square base and a surface area of 108 square inches. We want to know what dimensions will produce the box with maximum volume. So in this case, we are trying to maximize our volume. So the volume equation is going to be our primary equation. That means that this is the one we want to differentiate. So we're going to find a volume equation, and then we're going to find the derivative of this volume equation. For this type of problem, I think it's a good idea to start by drawing a picture. It looks like they don't give us a lot of information, but they actually tell us enough so that we can actually solve it. So I'm going to draw a box. And we know that the box is an open box and that it has a square base. So that doesn't really look like an extremely good box, but hopefully you get the idea. So we have a square base and we have a surface area of 108 square inches. So we know that all of the dimensions of the base are going to be the same. So like this side will be x, this side will be x, this side will be x, this side will be x. Those are all going to be the same. The height of the box, however, is not necessarily going to be the same value. So I'm going to call that h. We do need to give it a different variable because we don't know for sure if it's going to be the same. Hopefully you remember that the volume of a rectangular prism is length times width times height. So in this case, I have my length is an x, my width is an x, my height is h. So I have v equals x squared h. I'm off to an okay start. This is actually my primary equation. I will need to find the derivative of this. However, in order to find the derivative of this, I need my equation to be in terms of one variable. So that's going to be really important. You might remember with related rates, you had multiple variables and you always differentiated in terms of t. With optimization problems, that's not the case. We're going to get v is equal to one variable only. So let's go ahead. This is our first equation. I'll put a box around it. Now we need to find our second equation. The second piece of information that they give us is that the surface area is 108 square inches. So to find the surface area, you need to add up the areas of all of the faces of this prism. Keep in mind that it's an open box, so there's no top to it. So we're going to do the 5 sides that we have. So the bottom of this prism is going to have an area of x squared. Each side of it is going to have an area of h times x. Keep in mind that all of these are h's. So I'm going to have 4 sides that have an area of x times the height. So that's my surface area, and I end up getting 108 because they told me that was the surface area. So this right here is my secondary equation. The purpose of the secondary equation is to get your primary in terms of only 2 variables. You get a v equals and then 1 variable. So you're going to want to solve for whatever variable is easiest to solve for. If you try to solve for x, it's pretty challenging. So we're going to go ahead and solve this for h. And when we do that, we don't get something really nice, but we get something that works. We get h is equal to 108 minus x squared over 4x. So now that I've solved my secondary equation in terms of one variable, I can plug that into my original equation with my primary equation that has the v. You can simplify this on your own, but I will tell you that when you simplify it, you end up getting 27x minus 1/4 x cubed. So this is my primary equation. Once we have that, we are going to find the critical values of that. And when we find our critical values, then we're going to find the maximum. So we're going to find the maximum of this equation. So to find the maximum, remember, we are going to find the derivative, and then we set the derivative equal to 0. So I have a v and I have x's, so I'm going to find dv with respect to x. And when I do that, I get 27 minus 3/4 x squared. You can find your critical values by setting that equal to 0. When you do that, I'm not going to do all the work for it, but you can do that on your own. You get x equals plus or minus 6. We cannot have a negative side length. Keep in mind the x represents the side length. So I'm going to get x equals 6. So this one, it's really nice that this problem was written this way because you actually only have one possible value for x, and that one will give you a maximum. The only other thing that we need to do is we need to figure out what the height is. And so they said what dimensions will produce the box with the maximum volume. So the dimensions that will produce the box with the maximum volume are going to be a length and width of 6. The only thing we need to do now is find the height by plugging that x into our height equation. And when you do that, you find that it's going to be 3. So my maximum dimensions, I'm running out of room, so I'm going to do it up top, are going to be 6 inches by 6 inches by 3 inches. So this is a different type of optimization problem. They actually gave us an equation already. You don't have to find it yourself. So they tell us the speed of a runner in miles per hour is modeled by this function. For some reason on my video, the 1/10 did not appear, but this is actually the function that we should have. Hopefully if you printed out this paper, you have that in front of you. So the first thing I'm going to do for this problem, is write down what the variables represent. So they tell us that the speed is f, and that's in miles per hour. They tell us that the distance is m, and that's in miles. Okay, so they tell us the equation is f, and m is the runner's distance in miles from the start of the trail. We are finding the maximum speed of the runner for m is between 0 and 3. So I want you to notice that this equation is already in, there's a negative right there, by the way, I lost that. This equation is already in terms of one variable. So I have 2 variables total. I have the f and the m, but the f is written in terms of m, which is good. I only want one variable. This is my primary equation. I do not need another equation since I have f in terms of one variable. So first thing I'm going to do is actually simplify out this f of m just to make it easier to deal with. You can take the derivative without simplifying, but you hopefully noticed by now that simplification will often make your life a little bit easier before you take a derivative. If you haven't noticed that, then I'm telling you now. So now we're going to take the derivative of f with respect to m. So derivative of f with respect to m is going to give me negative 6/10 m squared plus 18/10 m minus 12/10. That 7 actually goes away. So I'm also going to simplify that a little bit just to make things easier to work with. Still not very nice numbers, but we can deal with it. So I'm going to find my derivative and set it equal to 0. That will give me my critical values. Then I can find my maximum. So I am actually going to factor out my greatest common factor, which is 3/5. And I end up getting m squared minus 3m plus 2. You'll notice I factored out the negative also, so my signs changed. Now when I factor it, I end up getting negative 3/5 times m minus 1, m minus 2. So that means that I have critical values at m equals 1 and m equals 2. So now I need to find my maximum value for my f, my maximum speed. What I'm going to do is figure out the speed at m equals 1, figure out the speed at m equals 2, but I'm also going to do it at m equals 0 and m equals 3. I have to use my endpoints. So now we're going to find all of these. We're going to find f of 0. That's the first endpoint. I'm going to find my f value at 1, at 2, and at 3. And I need to see which of those is going to give me a maximum value. I would say this is a good one to use your calculator for. Make sure that you're using the original equation, not the derivative. If you use the derivative, the middle two will be 0. We don't want that. And so when we do this, we get that f of 0 equals 7. We get that f of 1 is 6.5. F of 2 is 6.6, and f of 3 is 6.1. So actually, this value right here is my maximum. So my maximum speed, you'll notice it's right at the beginning. Remember that for our maximum and minimum value, we're looking at the y values. In this case, it's going to be the value of f. So my maximum speed is going to be 7. Remember that speed here is measured in miles per hour.